All right, well, move over, Al Gore. There's a new documentary out on the internet that attacks the issue of global warming. Take a look.
Consider this. Nearly all life on Earth could go extinct because of man-made climate change. It's hard to imagine Earth without life. We take life for granted, but life has not always flourished here.
Recognize that voice? Well, if you're an avid RT America viewer, you should. Big Picture host Thom Hartmann is the man behind the documentary. It's called The Last Hour, and it takes a different look at global warming, or at least one that is less popularized. It's a 10-minute film, so it's short, sweet, and to the point. Definitely worth a watch. Thom Hartmann joined me just a short time ago to talk about his new project. We started off by speaking about the Permian mass extinction, which is a period of time when over 90% of marine species and 70% of terrestrial vertebrae died off. The facts behind the event, known as the Great Dying, play a major role in this film. So I asked Thom why we, in the 21st century, should be worried about an event that happened over 250 million years ago. Listen.
Well, the Permian mass extinction, first of all, is the worst of the 5 mass extinctions that the planet has experienced. 96% of all life on Earth vanished. All 5 extinctions involved the crust of the Earth being punctured and greenhouse gases, principally carbon dioxide, coming out and warming the planet. They were all caused by global warming. And if you were in the case of the Permian, it started because of this massive lava flow up in Siberia and what's called the Siberian traps that went on for thousands of years. So if you were standing in, somewhere far away from where the lava flow was, on the other side of the continent, during the early years of the Permian, even the early 1,000 years of the Permian, looking around at the atmosphere, you might see that the sky's getting a little redder at night and things like that. But other than that, you would not have any idea that an extinction had started, it had passed a tipping point, that there was no way to stop it, and that within a certain period of time, 96% of all life would be gone. We use that not just metaphor, but example, because we are within possibly centuries, possibly decades, of tipping points that could lead to another mass extinction. The PETM is probably a closer example than the Permian, the Permian Eocene thermal maximum. But it's like we want to bring the word, the E word, the extinction word, into the conversation.
Sure, and you certainly did that with some very startling graphs that actually appeared in that film. Now, it's interesting because one of the things that I noticed was that you chose to bring climate scientists and geologists together to talk about this. Talk about why you decided to bring these two disciplines together.
Back in the 1960s, they were just beginning to figure out what caused mass extinctions. There was a huge debate, and the assumption, in fact, back then was that probably all 5 of them had been the result of meteorite impacts. It turns out only one was, the KT extinction 65 million years ago that killed the dinosaurs. They didn't really figure that out until the late 1980s, and they didn't really nail it down until the 1990s. They were still debating the Permian mass extinction, what caused that, up until the early 2000s. BBC did a brilliant documentary in 2002 called The Day the Earth Nearly Died, where they brought together a bunch of these geologists to lay out exactly why the Permian happened. And in that documentary, they talk about how this giant volcanic lava flow in Siberia produced a 6-degree warming Celsius of the Earth. And that was enough to warm the oceans 6 degrees, which was enough to melt the hundreds, the thousands of billions of tons of methane clathrate, methane hydrate, that is frozen as a lattice, kind of a slurry, like a snow cone thing at the bottom of the oceans. To melt that so it went into the atmosphere, this methane is 100 times more potent than carbon dioxide as a greenhouse gas. So this sudden eruption of methane into the atmosphere then doubled the rate of global warming, and that killed off all the life on Earth. And so, what we're pointing out right now is that methane is down there again. It's still there. And, we need to be very careful that we don't warm this planet up enough that the methane starts coming out. And it's already starting to come out from the Siberian tundra right now.
And Of all the different documentaries that I've watched, that others have watched about global warming, very few actually mention that methane that's on the bottom of the ocean. Why is this like one of the first times that we're actually hearing about this?
Well, this is sort of a follow-on to your last question. Why did we talk about the Permian and all this? Because we just discovered this. I mean, 2002 is real recent science, and there's a huge debate is the wrong word because there's no debate. It's an inquiry. Nobody really knows how much carbon is out there. The range, the guesstimated range for carbon in the form of methane in the frozen slurries around the continental shelves is anywhere from 3 trillion tons on the low end, which is enough to produce the Permian mass extinction. That was 2 trillion tons. So from 3 trillion tons on the low guess to around 10 trillion tons on the high guess, the amount that's just in the Arctic is pretty closely, a good guesstimate is probably 2 to 2.5 trillion tons. The CARV experiment, the Carbon Arctic Reserve experiment that NASA is doing right now, you can't visit their website because they're shut down because of the government shutdown, but we had one of their scientists in the video, and he was talking about how there's 40 to 50 billion tons of carbon that is ready to be activated right now. I mean, it's close enough to the surface that just a little bit of warming could bring it out. And then you get that positive feedback loop that spirals you into an uncontrollable global warming, which 5 times in the past history of the planet has produced an extinction where more than half of all life dies.
But at the same time, I know that viewers sitting at home are going to ask the question, if mass extinctions happen like this, where the ocean warmed up before without humans contributing to it, how are we contributing to it these days?
That's a brilliant question. Each time in the past 5 times, the crust of the Earth ripped open and carbon dioxide came out. 4 times it was apparently from tectonic activity, the continents moving around, massive volcanic eruptions as a consequence of that. 1 time it was because a meteorite punched through down near Cancun, punched through the surface of the crust. What we have been doing for the last 150 years is very methodically drilling holes through the crust of the Earth. And we're not doing it in a big clumsy fashion like a meteorite where you hit some areas that have a lot of carbon and some areas that don't have a lot of carbon. We're doing it very specifically, going just for those areas where we know that there's a lot of carbon, and we're pulling that carbon out in the form of coal, oil, and gas and burning it and throwing the carbon dioxide into the air. So we are, and we have been over the course of the last century and a half, replicating the mechanism by which the previous 5 extinctions happened, which is the puncturing of the Earth's crust and the release of this carbon dioxide.
And quickly, where can they find this documentary to watch?
lasthours.org.
Thank you so much. Thom Hartmann, host of The Big Picture, joining me with his new documentary.
Thank you, Megan.